It was 7:47 a.m. Eastern Time on October 29 when Avi Loeb, the renowned Harvard astrophysicist, quietly posted a set of new images on his personal page. They weren't just any photos. They were of Atlas, the third confirmed interstellar object ever detected by humanity, an icy, metal-rich body traveling through our solar system on a path that has baffled scientists since the day it was discovered. In those early hours, the scientific world held its breath. Atlas had reached its perihelion, its closest point to the sun, a moment that, according to NASA's Jet Propulsion Laboratory, could change our understanding of what truly drifts between the stars. But that critical moment passed in silence. No telescope on Earth could see it. No radar could track it. Atlas vanished, completely swallowed by the blinding light of the Sunday. Loeb's post came with a challenge and a warning. At the most crucial moment, when Atlas is bombarded by radiation of more than 770 watts per square meter, we cannot observe a thing. Is this the moment it breaks apart, scattering debris through the solar wind? Or are we witnessing something deeper, a phenomenon that doesn't belong to nature at all? For decades, Loeb has stood at the edge of mainstream science, questioning what others consider impossible. But this time, even his most skeptical colleagues fell silent, because the truth was, the timing was perfect, almost too perfect. Atlas had reached its closest approach to the sun precisely when it was completely hidden from Earth. For an entire week, it disappeared into a veil of solar brilliance, out of view, out of reach, as if it didn't want to be seen. And yet, Loeb's calculations showed something hauntingly coincidental. Had Earth been on the opposite side of its orbit 6 months earlier, or 6 months later, Atlas would have passed just 54 million kilometers away, close enough for humanity's most powerful radar systems to probe its surface. Goldstone, Green Bank, even Arecibo, if it still existed, could have mapped it in stunning detail. Instead, fate, or something else, placed us at the worst possible vantage point. When Atlas reached its defining moment, humanity blinked. The missed opportunity burned in the minds of astronomers around the world. December 19 would bring Atlas's closest approach to Earth, but even then, the distance would still be a staggering 269 million kilometers too far for any radar pulse to return meaningful data. The chance to see Atlas up close, to know what it truly was, had slipped away perhaps forever. Was it mere coincidence, or was it deliberate? The idea lingered, whispered in observatories and late-night discussions among researchers. Could Atlas's orbit, so precise, so aligned, be engineered? Could an object from another star system choose to hide? In the wake of its disappearance, a strange quiet spread across the scientific community. But that silence didn't last. Within days, radio telescopes across the planet began to coordinate in a way unseen since the golden age of SETI. The world's largest dishes in California, Spain, Japan, and Australia joined to form an unbroken network, scanning every frequency and wavelength that could hold a trace of Atlas's signature. It was the first true global watch, a planetary defense not against impact, but against ignorance. Even politics took notice. U.S. Congresswoman Anna Paulina Luna called for the declassification of satellite images taken on October 2, the only data that might show what happened before Atlas vanished behind the Sunday. Whispers spread through forums and research groups that those images contained more than sunlight and dust, that they captured a moment, a brief emission of structured light unlike anything seen from a natural comet. Researchers became detectives. They combed through spectral data, analyzed thermal maps, and reprocessed radar echoes. What they were looking for was simple movement, symmetry, intention. Could Atlas be changing its trajectory? Was it releasing smaller probes? Was there heat where no sunlight should be? Could its radiation signature reveal an engine? Every anomaly, every flicker, every unexplained signal became a possible clue. The deeper scientists looked, the stranger it grew. The question wasn't just whether Atlas existed, it was whether Atlas was alive, not in the biological sense, but in motion, in design, in purpose. To the naked eye, Atlas was a comet, or so it seemed. But comets don't travel with that kind of precision. They don't reflect light the way Atlas does. They don't survive the kind of heat that should have vaporized it completely. In Avi Loeb's words, Atlas is a paradox. Its physics doesn't add up. Its silence is louder than anything we've ever seen. As weeks passed, the list of unexplained features grew. Radar echoes hinted at a smooth surface. Polarization data showed metallic reflection patterns. Its orbit, only 5 degrees off the ecliptic plane, was so perfectly aligned with the orbits of the planets that the odds of a random interstellar object arriving at that angle were virtually zero. The path seemed chosen as if Atlas were designed to blend into the gravitational choreography of our solar system. If that alignment was intentional, it would be the first sign of something no human had ever seen an object behaving as though it understood orbital mechanics, hiding in plain sight among the planets. But that was only the beginning. In July and August of 2025, telescopes captured something no one had predicted: a gas jet erupting from Atlas, not away from the sun, but directly toward it. An anti-tail. In the physics of comets, that's impossible. Gas always escapes outward, pushed by solar radiation pressure. For Atlas, it was reversed as if it were absorbing light, not reflecting it. Scientists scrambled for explanations. Maybe a chemical reaction within the object's crust. Maybe magnetic field interference. But for others, the conclusion was far more radical. What if Atlas was harnessing the sun's energy? What if it was using light itself for propulsion, a solar sail, but not built by us? It was an idea that existed only in thought experiments and theoretical propulsion papers: a spacecraft using photon pressure as fuel, an interstellar traveler capable of maneuvering across cosmic distances without ever burning an ounce of matter. And yet, Atlas's anti-tail seemed to do exactly that. Some researchers at the SETI Institute called it plasma signaling, a controlled emission meant not for thrust, but for communication. If true, Atlas wasn't just moving through our solar system. It might be speaking. By late September, Loeb's estimates put Atlas at nearly 5 kilometers across, with a mass over 33 billion tons, 1 million times heavier than Oumuamua, the first interstellar object ever found. But despite its enormous weight, it moved faster than any known comet of comparable size. The numbers defied physics. It was as if an invisible hand was carrying it through space. At conferences and late-night debates, words like gravitational manipulation and non-Newtonian acceleration started to reappear, terms that had long been confined to fringe discussions. But this time, the data came from NASA's own tracking models. The deviation was small, but undeniable. Atlas was accelerating where it shouldn't. And it wasn't alone in its defiance. Its speed, mass, brightness, and chemical composition all contradicted what scientists knew about celestial mechanics. Some called it coincidence. Others began to call it design. By October, one truth had become clear. Whether natural or artificial, Atlas wasn't playing by our rules. It was rewriting them. When the first infrared scans from NASA's Deep Space Network came in, the data startled even the most cautious analysts. Atlas's surface temperature was abnormally consistent, hovering within a narrow band of thermal variation that made no sense for a tumbling rock. Natural comets heat unevenly, their surfaces cracking and venting as sunlight strikes them. Atlas, however, behaved as if it were regulating its own temperature, maintaining balance through some unknown process. It was as though it possessed a feedback system, a stabilizer, far beyond the scope of any natural body. At Harvard, Loeb began calculating the statistical likelihood that all these features could exist by random chance. The number he derived was staggering, 1 in 10 trillion. In other words, statistically impossible. Atlas wasn't following the known playbook of celestial mechanics. It was performing something intentional. That revelation spread through the global scientific community like a shockwave. If even one of those anomalies proved to be the result of technology, then humanity was no longer alone in the cosmos. The evidence grew thicker. Observatories detected small but precise deviations in Atlas's velocity, subtle course corrections impossible to attribute to outgassing. These adjustments aligned perfectly with the orbits of Mars, Venus, and Jupiter, a pattern too clean to be coincidence. Each planetary flyby occurred with near-perfect precision, as if Atlas were scanning, observing, collecting data. It was following a route, not drifting through space. And during its perihelion, when it should have been brightest, it was invisible. A disappearance that seemed strategic. Some researchers at Caltech and MIT began forming a theory. What if Atlas wasn't simply an object, but a machine? A probe operating on principles humanity barely understood. A relic of an ancient civilization that once navigated the stars with precision we can only dream of. Perhaps it had been traveling for eons, drifting from one solar system to another, activating only when encountering intelligent life. The clues multiplied. Spectroscopic data revealed an unusually high ratio of nickel to iron, far beyond anything found in natural comets. That ratio, coincidentally, mirrors the balance found in terrestrial alloys used for industrial applications. Its spectral lines hinted at nickel cyanide compounds materials that don't occur naturally in large quantities in comets, but are common in engineered metal processing. The implication was chilling. Atlas might not just contain metal, it might be made of it. If true, Atlas could be a hollow shell, a vessel, or worse, a storage chamber. The way it reflected sunlight supported that possibility. The brightness curve wasn't random, but followed a repeating geometric rhythm as if its surface contained structured panels. Some theorists proposed that inside there could be a core, a mechanical lattice, a memory vault, a data reservoir crossing interstellar space, a cosmic recorder traveling between stars, preserving the histories of civilizations long gone. Others took a more dramatic stance. If Atlas were indeed artificial, it could be a surveillance node, part of a vast network scattered across the galaxy, each piece monitoring the rise of new intelligent species. To them, its arrival wasn't a coincidence. It was a scheduled event, part of a grand cosmic timeline. But the anomalies didn't stop there. Atlas was almost bone dry, containing only 4% water, a fraction of what defines normal comets. Instead, it was rich in metals and silicates, its surface behaving less like ice and more like armor. The dryness suggested that it was not a remnant of frozen material, but something constructed to endure radiation, impact, and time. A spacecraft, perhaps, or the debris of one. More unsettling still was the light polarization data. Atlas reflected light in an inverted pattern, negative polarization never before observed in a natural object. It implied an active mechanism, altering how photons bounced off its surface. like a plasma shield modulating radiation. The polarization shifted in regular intervals every 16 hours, matching its rotation cycle. It pulsed, dimmed, and brightened in a rhythm too precise to be chance. It wasn't just turning, it was signaling. The last anomaly connected everything to an event that had haunted scientists for nearly 50 years. The WOW signal detected in 1977, a narrowband radio transmission from deep space that lasted 72 seconds, then vanished forever. When plotted in the sky, the direction of the WOW signal and Atlas's incoming trajectory overlapped within 9 degrees of coincidence, so improbable it defied randomness. Some theorists whispered that Atlas wasn't just a visitor. It was the answer to a message sent long ago. What if the WOW signal was a call and Atlas the reply? Or perhaps it was the reverse. The signal was a trigger, a remote command activating a dormant object drifting between stars. In that case, Atlas might have begun its journey toward our solar system nearly 50 years ago, responding to an instruction humanity didn't even understand at the time. As scientists around the world debated, Loeb attempted to quantify the impossible. Multiplying all the improbable variables, the orbit, composition, speed, polarization, and alignment, he concluded that the probability of Atlas being natural was effectively zero. His final statement was both thrilling and terrifying. If these numbers are correct, Atlas is not a coincidence of nature. It is the product of intent. That declaration divided the scientific community. Some called it visionary, others labeled it sensationalism. Yet no one could deny the data. No model could explain Atlas's motion, its reflections, or its heat distribution. It was as if it obeyed a set of physical laws unknown to Earth. Radio astronomers began searching the sky for narrowband transmissions near 1,420 megahertz, the hydrogen line, the universal frequency of intelligence. If any civilization wished to communicate across light years, that would be the channel. For days, they listened. The data came back filled with noise, cosmic background, and interference, but faintly, buried deep, there were rhythmic fluctuations matching Atlas's rotation period. No one dared to claim discovery, not yet. But those who saw the data felt a quiet certainty. Something was there, something deliberate. Meanwhile, astronomers prepared for the worst. If Atlas disintegrated under the sun's radiation, its destruction would be spectacular, a cosmic fireworks display brighter than any comet in living memory. Telescopes across the world were aimed and ready. But part of them, the quiet, unspoken part, hoped for something else, that Atlas would endure. Because if it survived, it would mean its nature was far stranger than anyone imagined. In press briefings, Loeb's words carried both awe and warning. If Atlas remains intact, he said, then the question becomes no longer about what it is made of, but who made it. The countdown to perihelion passed. The world watched and waited, but Atlas gave no answer. It vanished behind the sun's glare, silent, invisible, defiant. Only time would tell whether it would ever emerge again or whether humanity had just witnessed the quiet passing of a messenger from another world. When Atlas finally reappeared from behind the sun, a wave of anticipation rippled across observatories around the world. For days, telescopes waited, tracking the coordinates where it was predicted to emerge. Then, just before dawn, the first faint signature appeared on the monitors, a point of light, steady, unbroken, glowing softly against the backdrop of the stars. Atlas had survived. It hadn't broken apart. It hadn't disintegrated, it had endured. At first, the scientific community erupted in celebration. Survival through such intense solar radiation was nearly impossible for a natural comet. But jubilation quickly turned to bewilderment. The spectral data revealed that Atlas's composition had changed. The surface albedo was brighter, almost metallic, and the temperature readings no longer matched pre-perihelion models. Instead of cooling down as expected, Atlas maintained a steady thermal output. It was as if it were generating heat internally. For Avi Loeb, this was the confirmation he both feared and hoped for. The survival of Atlas defied the physics of known materials. Even the densest alloys would have partially melted or fractured under such stress. Yet there it was intact, stable, radiating a silent pulse of infrared light every 16 hours, precisely aligned with its rotation. The rhythm hadn't changed. If anything, it had become stronger. Across radio telescopes from Australia to Spain, faint narrowband fluctuations were again detected near the hydrogen line at 1,420 megahertz. They weren't random bursts. They were synchronized. The intervals matched Atlas's rotation, echoing like a heartbeat across the void. Analysts at SETI described it as a structured resonance, not a message, not yet, but something organized, controlled. Around the same time, data from the James Webb Space Telescope began to circulate through encrypted research networks. The JWST had managed to capture high-resolution infrared frames of Atlas as it passed beyond the sun's glare. Those images, leaked within hours, stunned the scientific world. They showed a smooth, glimmering surface, too uniform, too geometric. Along one hemisphere, a hexagonal pattern of thermal hotspots stretched in a perfect ring like panels on a machine. The symmetry was unnatural. The global media stormed with speculation. Was Atlas a vessel? A probe? A fragment of some stellar megastructure drifting across galaxies? NASA refused to confirm the authenticity of the images, while the European Space Agency called for cautious interpretation. But the public had already made up its mind. The era of disbelief was over. Meanwhile, something else began to unfold. Planetary radar data showed that Atlas's trajectory had subtly shifted after perihelion. It was no longer following the precise hyperbolic path predicted months before. Instead, it was curving just slightly, adjusting its velocity as if correcting its course. The change was minimal but deliberate. Gravitational modeling ruled out planetary interference. No natural force could account for it. Atlas was steering. At observatories in Chile and Hawaii, astronomers recorded the first visible rotation of the object's brightness pattern. The surface shimmered like metal under sunlight, the reflections moving in precise, repeating arcs. Some compared it to solar panels pivoting to maintain optimal exposure. Others refused to say anything at all. For Loeb, it was a turning point. In a private statement, later quoted in journals, he wrote, "If Atlas is navigating space intentionally, we are witnessing not astronomy, but archaeology, the study of something built, not born." The deeper they looked, the stranger it became. Within weeks, faint electromagnetic fluctuations began to appear across Earth's upper atmosphere. The variations were a minuscule less than a millionth of the planet's magnetic field strength, but they were synchronized with Atlas's 16-hour cycle. Compasses showed imperceptible oscillations. Radio towers picked up faint harmonic distortions. Some dismissed it as coincidence, others whispered that the connection was real. A quiet panic began to ripple through scientific circles. Could Atlas be interacting with Earth's magnetic field, testing it, mapping it, or perhaps responding to it? Every night, new data came in, and every morning, more questions followed. Loeb urged transparency. "We cannot approach this as superstition," he said in an international broadcast. "If Atlas is technological, then it represents a civilization capable of controlling energy on stellar scales. We must cooperate globally to study it." But cooperation proved harder than expected. Government agencies began locking down data. Observatories reported sudden maintenance interruptions. Datasets vanished from public archives. Rumors spread that a containment protocol had been activated, an agreement among major space agencies to restrict real-time data on Atlas until its nature could be confirmed. Still, fragments leaked through. Amateur astronomers around the world began capturing faint optical anomalies, intermittent flashes, as if Atlas were sending pulses of light back toward the inner solar system. The flashes occurred in prime number sequences, 2, 3, 5, 7, 11, a universal mathematical signature. If the pattern was intentional, it meant communication. But communication from what? The possibility alone ignited debates that tore through academia and public forums alike. Some believe Atlas was a messenger, a probe designed to observe intelligent life. Others suggested it was a remnant of a long-dead civilization, a drifting archive collecting data from every system it passed. And then there were those who saw it differently, as a warning, a silent sentinel recording not for curiosity, but for judgment. By mid-December, Atlas had stabilized beyond the orbit of Mars, glowing faintly in the dark, moving toward its closest approach to Earth, 1.8 astronomical units away. Not close enough to threaten, but close enough to watch. For the first time, humanity stood under the gaze of something older, colder, and perhaps far wiser. Loeb's latest paper called it the first evidence of a non-gravitationally accelerated interstellar artifact. Others called it fantasy. But regardless of interpretation, Atlas had already changed the world. It had broken the boundary between science and imagination. And then came the final mystery. As the object drifted through space, multiple observatories reported an unexplainable phenomenon, a faint, planet-wide resonance echoing every 90 minutes, barely measurable but consistent across sensors. Some called it a coincidence, some a side effect of solar radiation. Yet the timing was exact, matching the period of Atlas's internal thermal oscillation. It was as though Earth and the object were vibrating in harmony, sharing a rhythm across millions of kilometers. For Loeb, this was the most haunting discovery of all. If two systems separated by such distance can synchronize, he wrote, then information is being exchanged. Whether that information is natural or intelligent, we do not yet know. Days before its closest approach, the global network of telescopes prepared for full observation. The entire world was watching, and then suddenly the data feed froze. Transmission cut off midstream. Every observatory reported the same failure. Signal loss, system reboot, blackout. For 10 minutes, the planet fell into silence. When the systems came back online, Atlas was gone. No light, no trace, no coordinates, as if it had folded out of existence. The only record left was a faint residual spike on multiple frequencies, lasting 12 seconds, a pulse of radio energy centered on the hydrogen line. The world waited for an explanation. None came. In the days that followed, agencies released cautious statements, calling it a data anomaly. But those who had seen the raw transmission knew better. The 12-second pulse wasn't noise. It was a sequence. 6 hexagonal harmonics surrounding a central void, a pattern identical to the geometry observed on Atlas's surface. Whatever Atlas was, it had spoken one final time before disappearing into the deep. For Loeb, the conclusion was both humbling and inevitable. Atlas has reminded us that we are not observers, he said, but participants in a universe far more complex than we imagine. In the stillness that followed, one truth settled across the minds of those who had followed the mystery from the beginning. Atlas was not just a visitor. It was a mirror, a reflection of our hunger to know, our fear of insignificance, our endless search for meaning in the cosmic dark. And so, humanity waited once more for a signal, a flare, a whisper from the interstellar void. Whether Atlas would return or remain a ghost among the stars, no one could say. But its legacy was certain. It had blurred the line between science and myth, between knowledge and wonder. Somewhere beyond Jupiter's orbit, a small point of light moved quietly, defying gravity, defying logic, a silent witness drifting through eternity. And on Earth, beneath the cold night sky, humanity stared upward, realizing that the story of Atlas was no longer about discovery, it was about recognition. The moment we first understood that the universe was watching back,